In this tutorial, I will explain how to work with charts in AwareIM. In AwareIM, charts is one of the forms of presenting data returned by a query. Please watch the queries tutorial for more details about queries. In order to have a chart, we must first define a query that is looking for instances of a business object that the chart displays. The X and Y axis of the chart always display values of some attributes of this object. Let's look at some examples. I will start with some simple ones, and then I will show you more complicated, real-world examples. Let's recall our customer management application from the previous tutorials. In this application, we have the customer object. And we also have the contact node object. The contact node object represents a record of communication with a customer. Customer and contact node are related through an attribute in the customer object called communication. So the customer stores all its communication records. For more details about relationships, please watch the relationships tutorial. We have added the total communication duration attribute to the customer object. When a communication record is created, an operator enters the duration of the communication into the duration attribute of the contact node object. So it is possible to calculate the total duration of all communication records for a particular customer by summing the durations of all communication records for the customer. We have a rule on the custom object that does just that. And this is the rule here. For more details about business rules, please watch the business rules tutorial. Let's say now that we want our system to display the following chart. Assuming that we do not have too many customers, we will display customer names along the x-axis. The y-axis will then show the total duration of the communication with the customer. So we need to define a query and present the query as a chart. So let's create a new query, give it a name, and this query will be looking for all instances of the customer object. Let's now select the Display As property and select the Chart Radio button. The most important chart properties that we must specify are in this section here. We will display bars for each customer. Bars and lines belong to the standard chart type. But there is also pie, donut, area, and radar. Then we select the attribute that should be displayed along the x-axis. Customer last name in this case. A single chart can display multiple graphs, called series. For each series, you need to define the attribute that will be displayed along the y-axis for this series. We will have just one series for our chart. The type of the series will be bar, and the series will display the total communication duration attribute. Let's also choose a color of the bar. Let's not worry for now about different other options and see how the chart looks like. The preview window shows the chart, but we will look at the chart in the real browser. Before I test it, I will add the query to the menu of our application. For more details, about menus, please watch the Visual Perspectives tutorial. Everything is now ready, and we can see how the chart works. So I put the version under test and log into the browser. I have already added all the data to our system. Here we have 27 customers. Let's display our query. You can see a nice looking chart with customer names on the x-axis and total communication duration on the y-axis. Let's now add another series to our chart to display how many communication records each customer has. In our customer object, we have the communication count attribute that stores the number of communication records per customer. And we also have a rule that calculates this number by counting communication records that belong to the customer. This is the rule. Now we just need to add another series to our query to show this number on the chart. So let's go to our query and add another series. Let's make it a line, and the series will show the communication count attribute. Let's pick the color for the series. I will also include a legend to our chart, which will show what each series means. For this, I should also give each series a unique name that will be shown in the legend. Let's now turn the legend on. Let's see now how this works. So we'll log in again and run our query. I can see two series on the chart and a legend that explains what each series means. We can see here that there is not enough room for the customer names on the x-axis. Let's fix this by displaying names at an angle to the axis. To do this, we return to our query and go to the properties of the x-axis. Here I can change the rotation angle to 45 degrees. Let's look at some other properties that we can use. On this dialog here, we can change some general properties of the chart. Let's change its background color, for example. If we select a series, we can change some of its properties. Let's look at the properties of the bar series. We can change the opacity of the bar, for example. Let's look at the line properties now. Let's make the line dashed. We can also specify the tip properties, turn grid on or off, and change many other settings. Please explore them on your own after watching this tutorial. Let's see how the chart looks now in the real browser. So when we log in and run our query, we can see that the names are displayed at an angle, the line is dashed, there is a background color, and note also that bars became more transparent. Let's now look at some more complicated examples. In the remainder of this tutorial, I will be looking at some charts of the Sales Portal sample application. In this application, we have the Product Order Business object, representing an order for some goods. We also have the Employee Business object, representing a member of the sales team who sells these goods to the customers. An order is always created by an employee who makes the sale, and this order is considered to be the sale of this employee. The order has the employee attribute that defines the employee who made the sale, and it also has the date attribute which defines the date of the sale. The application has a chart which displays employee sales. Let's look at it. So now I'm in the Sales Portal application, and this is the chart I was talking about. It shows sales of a selected employee. Here I select another one. During the specified period. The x-axis displays the date. The axis itself is hidden on this chart. And the y-axis displays total sales for the selected employee during this day. How do we define a query for such a chart? Remember that the chart always shows attributes of some object. But where do we put the attribute that will store employee sales for a particular day? We cannot put it into the employee object, as we would need one attribute for each day. We obviously cannot put it into the product order object either. The common solution is to create another object that would store the data we want. In this case, we have the employee monthly sales record object. This object stores the date, a particular employee, and the total sales for this employee during this day. But how would we create instances of this object? For this, we would need a process that would be called at the end of each day, and for each employee, the process would create a new employee sales record for this day. This is the process, and this is the rule that does that. There is also a scheduling rule that calls this process at the end of each day. The rest is simple. We need a query that would find instances of the sales record object in a particular period for a particular employee and display it as a chart. Here is the query that does that. Note that the period is specified in the filters of their application, and the currently selected employee is stored in the logged in user object. The chart shows a simple line with the date attribute of the sales record on the x-axis and the total sales on the y-axis. Creating additional objects to store data that needs to be displayed on the chart is a common approach. However, if the x-axis of the chart shows a date, which is often the case, it is sometimes possible to avoid creation of additional objects. Let's look at another chart of the application. We're back to the sales portal application now, and this chart here shows revenue per month for the selected country in the selected period. Do we need to create an additional object for this chart? It would seem that we do. We could create an object that would store the date and total value of sales for this date, just like we did it in the previous example. However, in this particular case, the order stores its value in the total price attribute, and all we have to do is select the orders for a particular country in a particular period and aggregate their values for the dates in question. There is a way to do this without creating an additional object. Let's look at the query that displays this chart. As expected, it selects the orders in the specified period for the selected country. Let's now look at the chart. It shows the date of the order on the x-axis and the total price of the order on the y-axis. The most important bit here is that if we look at the properties of the series, we will see that it automatically aggregates dates using the sum expression. This means that the chart will automatically show not the prices of individual orders, but the sum of prices of the orders for the certain range of dates. Which range it is depends on the property of the x-axis. Here we can see it is specified as months. So the chart will aggregate prices for all dates of the same month. So in this tutorial, we have covered the basics of Where I Am charts. There is plenty more to explore. Pie charts, area charts, radar charts, and much more. For more details, please refer to the user guide.